Good morning, students. Welcome to the class of refrigeration and air conditioning. Now today we will going to discuss about different types of rotary compressors and their applications. Now before we start our discussions on different categories of rotary compressor, till now we have covered the introductory part regarding refrigerating compressor, then applications of compressor, classification, working of reciprocating compressor, rotary compressor. So in the first classifications or in the first class of compressor, I have given one classifications of compressor. That means compressor is generally classified in two categories: positive displacement type and rotodynamic type. Now this positive displacement type can be again divided into two categories. One is reciprocating type, another one is rotary type. Reciprocating type is generally a piston cylinder arrangement where the piston moves within the cylinder and to and fro movement takes place. Now in case of a rotary type compressor, generally a rotary part is present, and the boundary of that rotary part causes the positive displacement of the fluid to make the compression. Here the working fluid, if it is air or any other working fluid, maybe any type of refrigerant, so that air is compressed by trapping it in the reduced space that is formed by a set of engaging surfaces or set of blades. And one thing is to remember that in case of rotary compressor, the amount of clearance volume or the presence of clearance volume is very less. That is why they are having a very large volumetric efficiency. So that is one of the most advantage of this rotary compressor. Now what type of refrigerant that can be used in case of rotary compressor? We can use R12, R22, R114 ammonia as a refrigerant in case of different rotary compressors. Now according to the movement of compression components, a rotary compressor is again subdivided into various categories. It may be scroll type, it may be screw type, that is also known as roots blower, it may be roller type, and this roller type is again subdivided into two categories: single stationary blade type and rotating vent type. So today we will discuss all these types, all these categories one by one. So our first discussion will be on single stationary blade type rotary compressor. And regarding that, four different figures are given. Actually these four figures represents the movement of the rotary part within a particular casing or within the housing or within the cylinder, starting from suction to the up to the end of the process. Now if we look at this first figure, so what are the components that are present? It consists of a single stationary cylinder. See, one single stationary cylinder is there. One roller is there. That roller is also known as impeller. And one shaft is present, rotor shaft. Now this shaft has an eccentric on which the roller is mounted. See, if we look at this arrangement, this shaft has an eccentric on which, see, both the center of this roller as well as the center of this rotor shaft are not same. So one eccentricity is there. This distance is the eccentricity. So the shaft is mounted in an eccentric way on which the roller is mounted. Okay. Now a blade is slotted here. One blade is there. So here this blade is set into the slot of a spring, and this blade can be moved in and out in the slot to follow the movement of this, to follow the rotor when it rotates. Okay. Now since the blade, see, if you look at the two sides of the blade, see, in one side one discharge port is there, another side suction port is there. So you can say that, you can easily say that this blade can separate out this discharge and the suction port. Now since the blade separates the suction and discharge port, that is why this blade is also termed as sealing blade. sealing blade. And when the shaft rotates, the roller or the impeller also rotates so that it touches the cylinder wall. Okay. Now, starting from figure A up to figure D, different positions of the roller or the impeller are shown as the refrigerant vapor is being compressed. See, the roller is rotating in this direction, that is anti-clockwise. See, first figure, this is the second one, third one, and again the fourth one. So if we go one by one, so first figure, that is figure A, it represents the end of the suction stroke. See, when the roller is over here, suction valve will open, so the low pressure, low temperature air or the refrigerant will enter into the hollow portion between the roller and the cylinder. So it shows the end of intake stroke, that is the cylinder is full of low pressure, low temperature vapor refrigerant, and the beginning of compression stroke. So just at the end of suction stroke, as the roller is moving in this direction along with this rotation of the rotor shaft, so the suction port will be closed and the refrigerant enters into this intermediate zone that will be start to compress. So here the compression starts. Now when the roller rotates, the vapor refrigerant ahead of the roller is being compressed and the new intake from the evaporator is drawn into the cylinder. See, when the roller moves from this position to this one at figure B, so again this portion will be open, so again fresh charge will be introduced into this through this suction port, okay, into the cylinder. Now as the roller or impeller turns towards the mid position as described in the figure C, from this we compared to figure A. If we compare these two figures A and C, C is the mid position. Okay, so as the roller turns towards the mid position, more amount of the suction port will be fully open, so more amount of vapor refrigerant will try to enter or will be drawn into the cylinder, while on the other side it will be compressed. The previously drawn refrigerant will be fully compressed and that will be discharged through this open discharge port at the end of the compression stroke. So at the end of the compression stroke, as is represented in figure D, most of the compressed vapor is passed through the discharge port to the condenser, and again at the same time a fresh charge of refrigerant will be drawn into the cylinder. So by this way, due to the rotation of the roller or impeller interconnected with the rotation of the rotor shaft, the suction, discharge and the compression of the vapor refrigerant takes place. So by this way, a single stationary blade type rotary compressor works. And if you look at this four figure, see here the position of the spring is like this. Here the spring is just being starts to stretched or elongated. Here in the first figure, the spring is totally compressed. Second figure, it starts to stretched. Third figure, it is more elongated, and the fourth figure again after elongation it will be start to compress. So by this way, see the position of the blade is not changing. Okay, that is why it is known as single stationary blade type rotary compressor. Now our next classification is rotary blade type rotary compressor, that is also known as rotating vane type compressor, which is discussed or described in this figure. So what are the working principle of this rotating blade type or rotating vane type compressor? If we minorly look at this figure, it also consists of a cylinder and some slotted rotors. See, here the rotor is slotted, 4 slots are there, which contains number of blades. See, these dotted lines, these hash lines denotes the blades. This one, this one, this one, this one. These are the blades. And the center of the rotor is here also eccentric with the center of the cylinder. What is the center of the cylinder? Suppose the center of the cylinder is over here and the center of the rotor is here. So this one is also eccentric, just like the previous one. So center of the rotor is eccentric with the center of the cylinder. And the blades are generally forged against the cylinder wall by the centrifugal action during the rotation of the motor. This is the suction port, this is the discharge port. Now when the low pressure, low temperature vapor refrigerant from the evaporator is drawn through the suction port, and it will be entrapped between the two adjacent blades. See, this one is one blade, this is the second blade. So when through the suction port the vapor will be introduced or sucked, that vapor will be entrapped between these small spaces or small space. There is the two adjacent blades with the movement of the rotor, and it will thus get compressed. That means when this rotor will rotate, it will get compressed. And this compressed refrigerant at a very high pressure and temperature, after full rotation of this rotor at a very high pressure and temperature, will be discharged through this discharge port or discharge valve to the condenser. Now here the total assembly or the whole assembly in both the design, that means in the previous case or also in this case, is enclosed in a housing which must be filled with oil and remains in oil. Otherwise, more friction will be there and more water will be there, that will affect the performance of the compressor. So an oil film forms the seal between, here the function of the oil film is to form a seal between the high pressure and the low pressure side. When the compressor stops, the seal is lost and the pressure will equalize. And remember one thing, that rotary compressor are normally used in a single stage up to a capacity of 5 ton. So today is up to this. In the next class, I will discuss about the remaining 3 categories, that is roots blower, screw type and scroll type compressors. Thank you.